Hi guys. All right, so today I have to do the video a little bit differently because I need to have the calculator in the video like a lot. So come on over and I'll let you see how I normally teach you. So normally I sit here and like I write on the document, and then all you guys ever see is like the ink going. But today I need to have in the video like the calculator too, because there's so much to do like on every single problem. So this is my normal setup. I sit here and this is how I do everything. All right, but today let's get started a new way. So hopefully you're gonna be able, there's Coco. Hopefully you're gonna be able to see as well. And there's the filmer. All right, so I'm gonna try to do this. So hopefully you still can see as well, okay? Okay, so I have to keep it a little bit away because I have to be able to write as well. So just bear with me here trying to set up. Okay, all right, I think that's good. All right, so here we go. So day 4, normal distribution on the calculator. So we're gonna do what we did yesterday but we're gonna do it all on the calculator today. So normal distribution, remember what normal distribution is? A lot of data can be modeled after what's called the bell curve. And what we looked at and what we're looking at in the first question here is SAT scores. Most of us all get around the same, right? So that's why most of the data is going to fall in the middle. And then we're going to get the genius out here, and then we're going to get some people that maybe they filled in the wrong multiple choice answers or something. All right, so anyway, let's do this review question from yesterday. So it says at Arlington, okay. Oh. All right, sorry, technical difficulties here. Okay, at Arlington High School, 424 juniors recently took the SAT exam. On the math portion of the exam, the mean score was 510. So you can see 510. I like to take that data out on the side. And the standard deviation was 80. So I put that out on the side as well. And it says what percent of the math scores fell between 510 and 590. So let's do like we did yesterday. And I took the 510, I put my X bar right here. And then we're looking for 590, so this would be X bar plus 1 deviation. So I want to know what percent is this right here. So if we go back to yesterday's chart, which again, you're not going to have to memorize this, because we are just going to use the calculator, but we do like to show you where it comes from. So if we go back to yesterday's chart, right, between the mean and 1 deviation above, and we add those two percentages right there, 19.1 and 15, we wind up getting 34.1%, and that would be my answer. Okay. All right, so what we're going to do today, though, is I'm going to show you, like, why would we need the calculator to make these calculations if we can just look at this, you know, bell curve and memorize the percentages. Well, let's look at the next one. The next one says, what if we wanted to know the percent of the math scores that fell between 500 and 600? So look, where's 500 and 600 on here? They're not there. They're like deviations that are in between. So we do have a way to do it in the calculator. And we could have done that first one, part A there as well. So here's all the calculator steps. I want you guys to write these all down, keep them in your notes. So pause the video if you need to, and then we'll do them together. So the steps are, you know, you get a clean calculator page. A clean calculator page is just, you know, like we normally do. So new, don't save, right? And there, number 1, clean calculator page, okay? And then we're gonna go to menu, 652, and I'll show you what all that is. And then write down this red as well, because this is what we're going to plug in. The lower is going to be the lower number, like that guy. The upper is going to be like that guy. And then the mean, and then the standard deviation. Okay, and it's going to give us that same answer. So why don't we do that for that first question, okay, and see if we get that 34.1%. All right, so here we go. We go, I'll do it again. We go to a clean calculator page, and then the instructions say, I'll leave them off to the side there, right? Menu, number 6. You can hit number 6, but I'll just drag down so you can see it. 6. And then we're going to number 5, which makes sense, distributions. How data is just distributed. And then we're going to go to number 2, which is normal CDF, and that's just a cumulative distribution frequencies. That's what that is. All right, so see the lower bound? So that's going to be the lower number. So in this particular question, our low number was 510. Our upper number was 590. Now mu is the mean, remember, okay? Mu is the mean. So there's our lower, upper, then we put in the mean. Our mean was 510. And that's our standard deviation, okay? Standard deviation was 80. Okay, so there's all my info. And now let's hit okay. And there we go. Look, we got approximately, right there's my decimal, convert over, and we get 34.1%. All right, so for now on, we can just use the calculator to do this. All right, so let's do this next one. So the work that you should show, you know, because when you're using the calculator, you do have to show work, is norm, CDF, and then the lower, the upper, the standard deviation, no, sorry, the mean, whoopsie, mean, and the standard deviation. All right, and then we're just going to throw that in the calculator again. All righty, so here we go. You can stay on that clean page, you're good. Oh, all right, I cleared out. Okay. Oops. Okay, so we got menu. 6, 5, 2. Our lowest now is 500. Our upper is 600. Mu, which is our mean, 510, and our standard deviation was 80. Okay, there it is, 0.419, blah, blah, blah. Oh, God. All right, okay. Good times here. All right, so what did we wind up getting? We got, let me use a different color. Oh. Yeah, I'm fantastic at this. Okay, so 0.4194, blah, blah, blah. Remember, converting to a percentage, move the decimal 2 places to the right. And then they wanted it to the nearest 1/10 of a percent, so 41.9%. As easy as that, guys. Okay, isn't this great? But again, you know, we have to make sure that we use you know, the calculator a lot, so I wanted to show you all that. Okay, now it says how many scores fell between 500 and 600. Well, we just found out that it was 41.9%, right? So 41.9% of how many kids? Well, if we go back up to the tippy top, 424 kids took it, right? So we'll take our answer from above. Usually they say take your answer from above. So we'll take our answer from above. So 0.419, right? And I'll multiply that by the total amount of kids, which was 424. And we wind up with 177.656. And they said to the nearest integer. So we'll get 178 kids. Alrighty. Yeah, that's it. All right, so I think the rest of the questions are going to be all calculator. So look, this is what I would like you to really memorize for this as well. So when are we going to use this norm CDF, right? When are we going to use the norm CDF? Let me fix this better. All right, so we're going to use norm CDF anytime we want to find a percent, a probability, a proportion, a PPP, percent, probability, proportion. That's when we're going to use norm CDF. Okay, so let's go through all these questions. It says the weights of Siamese cats are normally distributed with a mean of 6.4 pounds and a standard deviation of 0.8. You can see I wrote out some of this because, you know, otherwise it'll take 20 years for me to make these videos. So, but what I do suggest is that you take the information out on the side. You know, I always like to do that. All right, and now I just showed you, right? This is your lower, your upper, that's your mean, and that's your standard deviation. So you can go ahead, put that in the calculator, and you should get a number like this. Now, no rounding yet, okay? It didn't ask me for a rounding, so we're just gonna leave all those numbers in your calculator. So the percentage is like 86.6 blah, blah, blah percent, right? But that's not what they want to know. This particular question is just asking for how many. So you'll take your decimal, you'll never convert it to a percentage, and you'll multiply it by the total amount of kitty cats. And we get 110.897. So use all those decimals right here, okay? Use all those, don't round. And it's closest to 111. Oh, come on. Oh, yikes. All right, so anytime again, we want to do percent, probability, proportion, we're going to be using norm CDF when it's normally distributed. Okay, so if the score is on a standardized test, again, here it is, normally distributed. So what are you guys thinking about? You're thinking about that bell curve, and just always think of the SAT. It's the easiest. Most everybody is right in the center here, right? And then the genius is out here, and you know, the kid who filled the bubbles in wrong is out here. And then heights, right? Most of us are around the same height, but then we got the really tall person or the really short person. So there's less data out there, less percentages. Okay, so if the scores on a standardized test are normally distributed with a mean of 560 and a standard deviation of 75, I'm just trying to make sure you see this good. Okay. Find the probability. So I'm asking for a P again. Remember, so a probability can also, be written as a fraction, as a decimal, as a percent. Find the probability that a test picked at random would have a score larger than 700. Okay, so watch, this is gonna be a little different now. It's supposed to be the lower and the upper, right? So the lower is 700. We don't have an upper. They're just telling me larger than 700. So I like to just call that a big number, right? We have 700 and then we just have a big number. So just write that down for now. I'll show you what to do in the calculator. And then there's your mean and there's your standard deviation. Okay, so let's see. Here's how we put this in the calculator. So we're gonna go to, again, menu, 6, 5, 2. My lowest number was 700. And now I don't have the other number, right? We said we're going to put in a big number because we just want something larger than 700. So you're just going to put in a really big number. So 100000000. Okay, it doesn't matter. You just put in something big. I wish there was an infinity button, but there's not. Okay, and then our standard deviation. And then our, nope, sorry, that was the mean. And then our standard deviation. Okay, and there we go. So we get 0.030, blah, blah, blah. Okay, so we got 0.03097, right? Looking like that. And now it says find the probability to the nearest 1/10 of a percent. So we'll move the decimal 2 places to the right. And then it says nearest 1/10. So nearest 1/10 place is right here. If I look 1 to the right, 5 or greater, push it up, 3.1%. Okay, so let's just review that again. So we find the probability that a test picked at random would have a score larger than 700. So 700 is your lower bound. You don't put an exact number in. You don't have to have what that maximum is. You just put in something very large. And then here's your mean standard deviation. So let's do the same thing, but now I'm going to ask for the probability that a completed test picked at random would have a score less than 500, right? So if it's less than 500, I'm going to put in a small number, and then 500 is my biggest, right? And you don't put in an actual number. I'll show you what to put in. You're just putting in something small, which the calculator actually does it for us. And then here's our mean and standard deviation. Okay, so I'm going to show you how to do this now in the calculator. Okay, so menu, 6, 5, 2. And you see that, what's on your screen right there? The -9E999. Leave that. That's what you're going to leave. It puts in a small number for you, so just leave that. That's scientific notation. Okay, it's going to be a tiny, tiny, tiny number. And now our upper is 500. Our mean was still 560. And the standard deviation was 75. Okay, so we all should have got something like that. All right, let's write that down. So 0.21185, blah, blah, blah. Nearest tenth of a percent again. So move it 2 places to the right. So 21.18, blah, blah, blah percent. Nearest tenth, here it is. Look 1 place to the right. If it's 5 or greater, push it up. So 21.2%. So it's all calculator. So if you have a number where you're starting with something and going bigger, then you'll do that number and then big. If you have a number and you're going less than it, so then you'll put in a small and you'll use the number the calculator gives you. So that's pretty much it. All right, so let's do a few more and you guys can just practice on the calculator. Historically, daily temperatures in July in Red Hook, New York are normally distributed. Again, as soon as you see that, normally distributed, right? It's the bell curve. And you know we can use norm CDF. They give me the mean, they give me the standard deviation, and it says how many of the 31 days of July can be expected to have temperatures of above 90. So above 90. So that's why you're going to do 90 and then a big number because you're going bigger than 90. Again, plug that into the calculator. I don't think you need to watch me do it again now. Well, maybe I'll do it with you one more time. Okay, so menu, 6, 5, 2. And now my small number is 90, right? And then I'm putting in something really big. So 1, 0, 0, 0, 0, 0, 0, 0. That's all you got to do, okay? Just give it something large. My mean was 84, and my standard deviation was 4. So we should get 0.0668, blah, blah, blah. And so now the question says how many, right, of those days? Well, approximately what? 6.68% of those 31 days. But if I'm asking for how many, I have to multiply this number times 31. So take the whole number that's on your calculator screen, right? It's already there. And now just hit times, right? Just hit times 31. How many of those 31 days? And we get 2.071, blah, 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 which is closest to choice 2. Right, hopefully this is going well, right? It's just all calculator, which is kind of good. All right, and then the rest of this, I just threw on some Regents questions, okay? So I don't think I'll do all these in the calculator with you now. You can just pause and read it and see what it is here, and it's all the same thing. So this one, and you can pause it if you want to, and go ahead and do it. Okay, so this guy comes out to be choice 2 after you plug this in. Next one is asking for probability, but again, probability, percent, proportion. Go ahead and pause it, give it a shot. This one comes out to be choice 3. 7 is asking for a proportion. And look, this one is looking for a diameter less than 3.7. So that's why I put in small and 3.7. Go ahead and try it. Pause the video. Okay, I got choice 1. And now last one is number 8. Number 8 says the average weight of a full-grown beef cow is 1,470 pounds with a standard deviation of 230. If the weights are normally distributed, what is that again? Bell curve. Ooh. What is the percentile ranking? So look, percentile ranking, hopefully you're remembering from the previous day. How do we get the percentile ranking? That's going like this, right? Adding up the percentages, starting at the bottom, which look, it makes sense because we're going small right, up to 1750. So we want to see where that cow lands. So if we put that into the calculator, go ahead and pause and do it. We wind up with 0.88827, blah, blah, blah. Now, nearest percentile ranking. So that is a percentage still, right? You're adding up all those percentages to get that percentile ranking. And we get 88.82, blah, blah, blah. And if we're doing to the nearest percentile ranking, that would be 89. So the 89th percentile ranking. So what does that tell me about that cow? He's pretty darn fat, right? If we would line all the cows up, right, he would be number 89, and 100 would be the fattest cow. Okay? All right, guys, I hope that that went well. I know that was a little different for us to do it like that, but I wanted to be able to show you all the buttons to hit in the calculator. Okay? All right, bye.